welcome to today's class. So today we'll be looking at few questions in heat energy, heat capacity, and specific heat capacity. All right, so we'll be starting with the first question. The first question on the board, we have: what is the heat energy required to raise the temperature of 2 kilograms of water from 20 degrees Celsius to 80 degrees Celsius? In brackets, specific heat capacity of water uh, is given as 4186 joule per kilogram Celsius. So, and then we have the options. So, how can we be able to solve this problem? Okay, so the first thing you have to do is to write down the given parameters. So, what are the given parameters from this question? So, we have that we're asked to, first of all, solution. We are asked to find the heat energy. So, the heat energy is H, okay, which is not given. Then we have temperature of 2 kg. This 2 kg is mass. So we have that our mass is given as 2 kg. So temperature of 2 kg of water from 20 degrees Celsius to 80 degrees Celsius. That means it is change in temperature. And change in temperature is theta 2 minus theta 1, where we have 80 minus 20, which will give us what, 60 degrees Celsius. And then we have specific heat capacity as 4186 joule per kilogram Celsius. All right, so what's the formula that will connect this? So we have H equal to MC delta theta. All right, so now we impute the given values. So we're asked to find the heat, and this is the heat. H stands for the heat. So we have mass given as 2 times C, that's specific capacity. So we have 4186 times delta theta, which is 60. So to multiply this now, okay, let's make use of the calculator. So make use of the calculator, we have this right here to use. So, okay, all right, so we have multiplying this, we have 2 times 4186 times 60. So 2 times 4186, 2 times 4186 times 60. So we'll have 502320 joule as the answer. So this is the answer. All right. Okay. So now let's look at the second question. Now this is the second question. So a 5 kilogram block of copper has a specific heat capacity of 385 joule per kilogram. So this is our heat capacity. This is the heat capacity given, and this is the mass. What is the heat capacity? This is the specific heat capacity. Now take note that our heat capacity, okay, heat capacity is, the symbol is what? Okay, heat capacity is equal to MC. All right. So, but in this question, we are given the heat capacity. We are given the specific heat capacity, and C is the specific heat capacity. And if we have that C is the specific heat capacity, what is the heat capacity? So if you read this question well, you notice that the mass is given, the specific heat capacity, which is 385 joule per kilogram Celsius, is also given, but we are asked to find the heat capacity. And this is the connection between the heat capacity and the specific heat capacity. So what is the heat capacity? All right, to calculate this now, we have that the heat capacity is not known, then the mass is given, which is 5, and then we have the specific heat capacity as 385. Okay, so we'll multiply the calculator to get the answer. So that will be 5 times 385. We have 1925 joule per Celsius. Joule per Celsius is the unit of heat capacity. So this is the answer. All right, take note that C is called specific heat capacity. Specific heat capacity. All right. Okay. YMC is heat capacity. That's when you join mass and specific capacity together, you form what? Heat capacity. All right. Let's look at the third question. All right. So we have calculate the specific heat capacity of a substance. Calculate the specific heat capacity. So here we asked to calculate the specific heat capacity. So how are we going to be able to do this? To be able to do this now, we have, if 2000 joule of heat energy is required, we are given the heat. So we can, let's use this side for the problem. So we are given the heat, okay, as 2000 joule. All right. And then we have of heat energy is required to raise the temperature, okay, of 4 kilograms. So we're also given the mass. The mass as 4 kilojoule. That's kilogram of the substance by 5 degrees Celsius. So that's our temperature. So our theta is given as 5 degrees Celsius. Calculate the specific heat capacity. So that's our C. Now you remember that there's a connection between these given parameters, and the connection is H equal to mc delta theta. H is equal to mc delta theta. Take note of that. Where H is the heat energy, m is the mass, C is a specific heat capacity, y delta theta is the change in temperature. But in the given question, there are no two given temperature, just one temperature. That means that the given temperature is 5 degrees Celsius. So imputing the given values, we have that this is our H, which is 2000, and then our mass, which is 4 times the C, which is specific heat capacity, times the 5. So since we have this now, we divide through with 4 times 5 divided by 4 times 5. So we have 4 cancel out 4, 5 cancel out 5. We have 4 times 5 give us 20. So we then have 2000 divided by 20 is equal to C. So then when I have 0 here, cancel 0, and then 2 into this side, we have 100. So that means that C will be 100 joule per kilogram degree Celsius. That's it for our specific capacity. So that means that here we have the C is equal to 100 joule per kilogram degree Celsius. So in the given options, the one that is 100 is this. So that means the answer is option B. Okay, so we have been able to solve to provide answer to number 1, number 2, and number 3. So we'll be looking at number 4 now. All right. So we have a 100 kg block of aluminum has a heat capacity of 9020 joule per Celsius. So here we are given the heat capacity. And remember the symbol for heat capacity is MC, okay? But we may not likely use this, okay? So we'll be using heat capacity. So heat capacity is 9020 joule per degree Celsius. All right, what is its specific heat capacity? Immediately you hear specific capacity, that means that there's a connection between the heat capacity and the specific heat capacity. Therefore, we'll be using H equal to MC, where H here will stand for our heat capacity, and then this is a symbol for the heat capacity. So this is the connecting formula between heat capacity and specific heat capacity. So what is heat capacity? 9020. And then what is our mass? The mass given here is okay, so we have that this is 9020, and then we have what is the heat capacity. The mass given is 10 kg, so we have 10 here, and then we have C. So divide both sides with 10, so we have 10 cancel out 10, and then 0 cancel out 0. We now have that specific heat capacity is 902 joule per kilogram degree Celsius. So that means that the answer is option A. So the answer to this has been provided. All right, let's look at number 5. We have a 2 kilogram block of copper has a temperature increase of 5 degrees Celsius. When 3850 joule of heat energy is added, what is the specific heat capacity of copper? Now we have this, okay? So the first thing you have to do is to write down the given parameters. So the mass given is 2 kilogram. Why the here they say temperature increase, which means that's our temperature, that's theta 5 degrees Celsius. All right. When 3850 joule is given, so we have that heat is given as 3850 joule. What is the specific heat capacity? So we have to calculate the specific heat capacity, which is C. All right. What's the connecting formula? H equal to mc delta theta. Make C formula subject, okay? But we can also apply the given values for each of the parameters that we have listed out here. So we have that H is 385, then M is 2 times the C times 5, divide by 10, okay? Divide by 10, all right? So 2 here cancels this out, because 2 times 5 will give us 10. So it's still the same thing, okay? If you don't say 2 times 5, you can just bring it down, and then you have 2 down here, 5 down here to cancel out each of these, and then you have that gone. And then you have 385 divided by 10. So let's use calculator. So we have 385 divided by 10. So we have our answer to run in decimal places, which will give us 3 that which will give us 38.5. So that means that what we're going to have is 38.5, 38.5, okay, 38.5 joule per kilogram degree Celsius. All right, so this is it. Okay, watch, look at this now. So this is 30850. So when you have this, we have 385 degrees Celsius. So we have 3850 divided by 10. So we have 385. So the answer is 385, which is option A. So option A is the answer to the question. All right. So this is how to solve problems in specific heat capacity. All right. Thank you for watching. Do well to subscribe.